So now we're going to get a little bit more practice factoring perfect square trinomials, recognizing when we have a perfect square trinomial, and also noting that even if you don't recognize that you have a perfect square trinomial, you can still factor it using methods that we've used before, but it's awfully helpful if you do recognize it. We're going to factor the following expressions. The first one is x squared plus 10x plus 25. Okay, so in a perfect square trinomial such as this, it's just as easy to ask yourself, okay, so this is a trinomial, its leading coefficient is 1, so what are the factors of 25 that add to 10? Well, 5 and 5, right? All right, so we're going to have x plus 5 times x plus 5, or x plus 5 squared. Okay, so that original step of asking yourself, factors of 25 that add to 10, you don't even need to do that if you notice that it's a perfect square trinomial, right? Because what we really have here is x squared is obviously a perfect square, and 25 is a perfect square, right? And so in the middle, do we have twice 5x, right? What's 2 times 5x? Well, 10x, right? Yeah, so if you notice that, okay, you can just factor it knowing what we know about perfect square trinomials. The middle term is positive, right? So we know we're going to have x plus something. Yes. And of course we can check this, right? So x plus 5 times x plus 5. Okay. FOIL it. X squared. X times 5x is 5x. 5 times x is 5x. 5 times 5 is 25. Okay, so we have x squared, 5x and 5x is 10x plus 25. Very nice. Okay, easy peasy. All right, so like I said, depending on the cases that you have, noticing that you have a perfect square trinomial can be really useful. Sometimes it's kind of like 6 to 1 half a dozen of the other, right? So for example, this next one, 64y squared minus 48y plus 9. So I don't immediately even see any factors I could pull out of there. That's the other thing. If there are factors you can pull out, you can. But 9 doesn't go into 64, nor does 3, right? So we're kind of stuck there. But I notice that 64 is a perfect square, right? 8 squared. And 9 is also a perfect square, right? So we just need to kind of look at that middle term and determine, okay, is this a perfect square trinomial? So we've got 8, quantity 8y squared, right? And then we've got minus in the middle. Now the ending term is 3 squared, right? That's 9. But the middle term would have to be twice 8y times 3, right? So I'm thinking about what A and B are. A would be 8y and B would be 3, right? So when I multiply them together, I would get, let's see, 8 times 3 is 24, times 2 is 48, right? Does that work? Yeah. Okay, so that means that this would factor into 8y minus 3 quantity squared, right? 8y minus 3 times 8y minus 3. Okay, just knowing that we have the perfect square trinomial. If you don't believe me, let's check it. So we have 8y minus 3 times 8y minus 3. Okay, 8y times 8y is 64y squared. 8y times negative 3y is minus 24y. Negative 3 times 8y is minus 24y. And negative 3 times negative 3 is positive 9. Okay, so we had 64y squared. Negative 24y minus 24y is minus 48y plus 9. Okay, is that what we started with? It is, right. So now with this next example, 100t squared plus 40t plus 4. Okay, now I notice that 100 is a perfect square, as is 4. The other thing that I notice is that 40, 140, and 4 are all even, right? So minimally we could pull a 2 out of there, but it might mess with our perfect square trinomial. Is there anything bigger than 2 that we could pull out of there? Could we pull 4 out? Well, 4 goes into 40, and it also goes into 100, right? So pulling 4 out of 100t squared would leave us with 25t squared. Pulling 4 out of 40t would leave 10t, yes. And factoring 4 out of 4 would leave just 1. Now, once we've pulled that GCF of 4 out of there, do we still have a perfect square trinomial? We actually do, I think. So if it's helpful for you to write out the A and B like I did in the previous example to help see it, go for it. I notice that 25 is a perfect square and 1 is also a perfect square. Does that mean that it's a perfect square trinomial? It might. Depends on how the middle term goes, right? So if we think about what the square root of 25t squared is, that's 5t, right? And we think about the square root of 1, which is 1. Well, 5t times 1 is just 5t. When you multiply it by 2, that should be the middle term, okay? 5t times 2 is 10t, which is our middle term. Okay, so we've got it. This should work. So factored, square root of 25t squared is 5t. Square root of 1 is 1. So we're going to have 5t plus 1 quantity squared. And it's going to be plus 1 because our middle term is positive. Now, even though I just kind of talked through that, the logic of it, how I knew that the middle term was going to work out, sometimes, even if you don't know if the middle term is going to work out, you just notice that A and C are perfect squares. I have been known to just assume that it's a perfect square trinomial, and then come down here in your check. If it's not a perfect square trinomial, that will show itself really fast, right? Okay, so leave that 4 alone, and we're going to FOIL 5t plus 1 times 5t plus 1. 5t times 5t is 25t squared. 5t times 1 is 5t. And that will be our outer and our inner term, yeah? And then 1 times 1 is 1. So then that gives us 4 times 25t squared plus 10t plus 1. Okay? All right. If we distribute the 4 through, 4 times 25 is 100. So we get 100t squared. 4 times 10t is 40t. And 4 times 1 is 4. Okay, so we get back to what we started with, that original expression. Okay, now I want to show you something really quick. This is a great little example, so I'm just going to do a little aside. Coming down here. Let's say, because I noticed before I pulled that 4 out, noticed that I had a GCF to pull out. I also noticed, hey, 100 is a perfect square and so is 4. So if I had just factored it from right there and I had said, okay, well, what if I had 10t plus 2 quantity squared? Would that have factored out the same way? It would, but notice something here. 10t plus 2 times 10t plus 2. You can factor a 2 out from both of those binomials, right? So you could say, okay, so 2 times 5t plus 1, right, times 2 times 5t plus 1, right? I'm factoring a 2 out from both of them. And so the 2 times the 2 gives us the 4, right? So I end up with 4 times 5t plus 1 quantity squared, which is the same thing I started with, okay? So even if you had seen that, like, oh, it's a perfect square trinomial, and then notice to factor out the numbers later, you could still get there. It's just a matter of what you notice first. Always, in our training with the factoring, we encourage you to factor out the GCF first because it just makes the numbers through the rest of the problem usually a lot easier to deal with. Okay, so let's do this last example. I don't notice any perfect squares right off the bat. I've got 18r squared minus 12r plus 2. So, but I do notice 18, 12, and 2 are all even, right? One of them being 2, so we can pull a 2 out. So let's do that. So if I've got 2 times the quantity 9r squared minus 6r plus 1. Aha! Okay, so 9r squared minus 6r plus 1, is that a perfect square trinomial? I think it is, right? 9 is a perfect square, as is 1. So I think of 3r times 1, which is just 3r, times 2 is 6r, right? So since our middle term is negative, when we factor this, we'll have 3r minus 1 quantity squared. Okay, so we end up having 2 times the quantity 3r minus 1 quantity squared. Such a quick way to factor if you notice you have a perfect square trinomial. Just for good measure, you know, I like to check. So I'm going to expand the 2 times 3r minus 1 times 3r minus 1, and we'll check it here. So leave the 2 alone. We're going to FOIL that. 3r times 3r is 9r squared. 3r times negative 1 is minus 3r, and that will be both our outer and inner term, right, for the middle. And then negative 1 times negative 1 is positive 1. Okay, so we're going to have 2 times 9r squared minus 6r plus 1. Okay, and then we have to distribute the 2 through. 2 times 9 is 18r squared. 2 times negative 6 is minus 12r in the middle. And then 2 times 1 is just 2. Okay. 18r squared minus 12r plus 2. Did we start with that? Yes, we did. Okay. So we can see how this method saves us some time. Noticing the perfect square trinomial can help us factor things very quickly.